Today we're going to be working on this Xbox Series X, and this has been sent in by a customer because it apparently let out the magic smoke. So the customer was playing on it absolutely fine, and then all of a sudden it just went poof, smoke started pouring out the top of it, and that was the end of it. It no longer turns on. So we said we'd try and fix it, as long as he pays me, of course. So with that being said, my name's Hakko, I'm an electronics technician. I mainly work on games consoles, but I do work on other stuff as well. So if that's the sort of stuff you're into, be sure to get subscribed and turn on the bell notifications. That way you don't miss any future videos. And if you need to organise a repair, you can get in touch with me at thecoder.repair. And if you need parts and supplies for the Xbox Series X or any other console, you can buy those on my online store at consolefix.shop. But with that being said, let's get into today's repair. That was probably the quickest intro ever. Nice. Okay, so yeah, apparently this has let out the magic smoke. So we're going to power it on and we're going to see what's going on with it. Or rather, we're going to apply power to it and see what's going on with it. Because apparently it doesn't power on. So yeah, there we go. So let's just grab a power cable and plug it in because we love danger. And yeah, it's stone dead, nothing at all. Okay, cool. So yeah, this could be a number of things. It could be a number of the reasons why this has let out some smoke. It could be the power supply, in which case it's going to be a pretty boring video because I'm not going to be opening up the power supply. The reason I wouldn't be opening up the power supply is because if you've watched any of my videos in the past where I've attempted to repair a Xbox Series X power supply, you can't even get to the parts. Unfortunately, the parts are all encased in some kind of putty, and you just can't get to the parts at all without damaging the board. It just takes way too long to remove all of that putty, and yeah, it's just really not worth doing. So yeah, I'm not going to be attempting to repair the power supply. If it comes to that, I'd just replace it, and it would be a pretty boring video. But I do have a rule: if I hit record, it goes out. But let's just warm up this sticker. This has definitely been opened before at some point. That was way too easy to get to underneath the sticker there. So the reason I warm these up is just to help with removal. It helps to remove the sticker without damaging it, exactly like this customer would have done, because it looks like it's been opened. So yeah, and I can see some finger marks and stuff on the sticker itself. You can't really see it because of the lighting, but yeah, there's finger marks and stuff on the sticker, so that's definitely been inside. Someone's definitely been inside this. But that's absolutely fine. I do charge a bench fee of £20 these days because I just kept getting too many jobs which other people had worked on. So either way, at least now, I get paid something for my time, even if it's not much, you know, if I'm not able to fix the console. So yeah. There is a £20 bench fee on all repairs now, apart from basic repairs like HDMI ports and overheating issues. Everything else does incur a bench fee because I need to protect my own interest and I need to get paid for my time. So, yeah, that's why I do it. Well, that's why I've started doing it. So, I don't know whether the customer's actually attempted a repair on this. However, that is broken. So there's a little gap here, so that screw thread is damaged, which means that it's been over tightened. So yeah, that's something to note. Alright, so I'm in the console enough to start doing my tests then. This is a V1 board, so it's going to be one of the original release consoles. And the reason I know that is because there's markings on the board itself, you know, so like the capacitor markings and stuff like that. So if there's no markings on it, then it's going to be a V2. If there's markings on it, it's a V1. And there's also going to be a metal plate underneath here as well, covering the APU. So if we just take a look, yep, it is a V1. So you can see the silk screen and stuff. I was looking for the words, but yeah, it's called silk screen. So here's what I want to do then. The first thing I need to do is check the power supply, because I don't want to assume that we've got a board problem and sit there going through a rabbit hole hunting for a board problem when it's just a power supply problem. I think it was Jessa Jones who says, I think it's Jessa Jones from iPad Rehab. Check her out on YouTube, by the way. Absolutely fantastic channel. But I think it's Jessa Jones from iPad Rehab who says Don't assume that you have a component problem until you've confirmed that you don't have a parts problem. And specifically, she's talking about screens, for example, on iPhones, because that's what she specialises in. However, the same applies for consoles and stuff. You know, don't assume you've got a board problem just because it's not turning on, when it could be a power supply problem, or it could be, for example, the disk drive motherboard is shorted and that's causing it to not turn on, or even so much as the fans shorted and that's causing it to not turn on, right? So it could be absolutely anything. So what I'm going to do is I'm going to go into voltage mode on the multimeter, and I'm going to check for 12 volts on the power supply. And why am I in AC volts? DC is what I want. And yeah, so we've got no power on the 12 volt rail, or on the 12 volt connector. There's nothing. It's just stone dead. So if I go into continuity mode then, so continuity mode is going to beep when we complete a circuit. So for example, there's a ground and this plate here is connected to ground. So if I just touch that, then you'll hear it beep because the path has been completed. So we're basically creating a bridge from here to here because it's all ground, right? Same as over here, it's ground, over here it's ground, etc, etc. And basically what that is going to allow me to do is it's going to allow me to check and see if any of the 12 volt rails are shorted to ground. So we can start off with this rail here. So that's the 12 volt for the south bridge board, for the top board, and that is absolutely fine. And then we can go ahead and check the 12 volt connector on the other board underneath and see if there's a short on that, and there's not. So basically these boards appear to be absolutely fine. There doesn't appear to be anything wrong with them. So it looks like we do have just a power supply issue. So what I want to do then is just have a look. I don't know. I've got two power supplies here. One works, one don't. I think it's going to be that one that don't work because it looks like I've tried to take it apart. So that's going to be one that I looked at and just decided that I can't do anything with it, sort of thing. So if I just pop this in here like this, pop that in there, and then if I take my disk drive here, because I don't have a Nexus board immediately to hand, by Nexus board I mean the little PCB what has the power button on it, I'm just going to offer up a disk to this. It doesn't have to be, well, it doesn't even have to be a disk really. I can just offer up a piece of metal and it should turn the console on. Well, no, it's not going to, is it? Because I haven't got it plugged in. Because I'm an absolute fool. But, yeah, never mind. Alright, let's try it again. No, it's not powering on. Alright, well, we might have other issues here then. Let me just double check and see if I've actually got 12 volts now. Yes, I have. So I've got 12 volts. So let me just remove this Nexus board from this customer housing. And it's still not powering on. That is very, very odd. Right. Okay. So it's still not powering on even with another power supply installed. A working power supply installed. Interesting. Okay. So we do have a faulty power supply by the looks of it. But we also have another issue. So now we need to figure out what the other issue is. So what we can do is if we take the power supply, so if we disconnect this ribbon and we take the power supply and we just connect up to the south bridge board like that. So we just apply power to the south bridge board and then we connect up the Nexus ribbon and try and power it on. In theory, if the south bridge board is working, we should get power. And we don't. Okay. So let me just make 100% sure that my power supply is working as I suspect it is. I have just checked for 12 volt and it did come up 12 volt, but let me just double check. So I've got my own Xbox here. This is taken apart purely because I needed to use the power supply a couple of weeks ago. and then I ended up replacing the power supply afterwards, and that's what this power supply here is. So let me just make sure that this turns on. Yes. So that turns on with my power supply. What about my board customer's power supply? This is risky. I really should not be doing this. So my board, customer's power supply, so that's the one that hasn't been opened. Unless I was just not getting a connection on the power supply when I tested it. And it actually isn't a power supply issue. Let's have a look. No, so we've definitely got a dead power supply. But we have other issues here as well. So here's the thing then. So a lot of places that I know of, what they would do is they would figure out right now that we have a faulty power supply, but we also have a board issue, right? So what they would say to the customer is, it's going to cost you, for example, £200 because I've got to replace the power supply and I've got to replace the and I've got to repair the board issue. However, what they're not going to be taking into account is the fact that they've got to replace the power supply anyway. So yes, I've spent an extra 5 minutes figuring out that this power supply is faulty, but that's only 5 minutes. It doesn't justify charging for 2 separate repairs, right? So what I'll do with this is I'm going to try and figure out what the issue is with this. And if I can figure this out, then what I'll do is I'll charge my normal repair cost for that repair and then just have to add on the cost of a power supply. So I'm going to try and figure out what's going on with it, and then I'll call the customer and just see if he's happy to pay whatever it's going to cost. So the cost of a power supply is about £40. So in reality, the customer's going to be looking at around about between £100 to £120 for this repair, because my standard repair cost is going to be between £60 to £80 for most labour. You know, I basically charge pretty much a flat fee, or I charge like a couple of flat fees depending on how long it takes me. So if I can figure this out in 5 minutes, I'd charge £60 labour and then the cost of the power supply. And if it takes me, you know, an hour and a half, then I'll charge probably £80, £90, £100 labour, depending on how much it actually takes and what kind of components it takes as well. Obviously, I always have to take parts into consideration for it. So, yeah. Anyway, I'm going to strip this down fully and figure out what's actually going on. So there is a way that I can tell if it's going to be the SafeBridge board or if it's going to be the APU board that's at fault. So if we go here, what I can do is I can take the customer's main board and connect that up with my SafeBridge board. And I already know what a lot of people are going to be thinking. You're going to be thinking, it's paired, you can't replace it. I know that. I understand that. It is paired. So there's a BIOS chip on the SafeBridge board. Basically, that's going to prevent me from swapping these boards over just like this, right? So this is my SafeBridge board. This is a customer's APU board. And it is going to prevent me from doing that. However, if I plug this in right now and we still don't get any signs of life, then I know that we've got an issue with both the SafeBridge board and the APU board. And the reason I'll know that is because I've already tried just powering on the SafeBridge board and it didn't work. So I've definitely got a SafeBridge board issue, but I need to find out if there's a APU board issue on top of that, because then it would get to a point where it's probably uneconomical to actually continue. So let's plug this in. I'm going to give it some juice, and it's very likely, occasionally you'll get really lucky and it will work because the keys all match, but most of the time, 99.9% of the time, it's going to attempt to turn on and then shut straight off. Oh, that's not good. Oh, hang on a minute, hang on. Did I just put the wrong power supply in this? I think I've just took the customer's faulty power supply and tried to use that. Hang on, let me show. This is why I should be labelling parts. But it doesn't matter because I know the customer's power supply is faulty and I know that mine is good. So either way, it doesn't make a difference. Let's try now. Did we get a beep? Yes. Oh wow. Oh no. Alright, maybe not. It tricked me. I thought that was going to power on. Okay, so yeah, that's completely fine. So I know that I've got an issue with the customer's Southbridge board, and the customer's APU board should be okay. The one that we can't mess around with changing should be okay. So if I just connect this up now, chances are my board is now not going to turn on, because it's got the customer's faulty Southbridge board in it. I know this is a bit confusing to you guys. I am keeping track of parts, don't worry. It's all in my head. Yeah, so absolutely no signs of life with the customer Southbridge board with my APU board. And I know that mine obviously works fine. The only reason I stripped mine down is purely because I wanted to use the power supply off it, because I didn't have one for a customer. And it's going to be the same case again. I'm going to have to source another power supply for my customer. So yeah, so this is a customer Southbridge board. So I'll pop that there. This is my Southbridge board. So I'm going to pop that, if I can get the thing off, there we go. I'm going to pop that back onto my APU board, because my APU board works. Everything's fine on mine. And yes, I do have the disk drive to mine as well. So that's all fine. I can put mine away. I'm done with it. Yes, this is a mess. It's all everywhere, I know, but I am keeping track of it, I promise. So now I'm going to get rid of the customer's parts. So I'm going to get rid of that. I'm going to move that to there. I'm going to get rid of that. I'm going to get rid of that. And that. Okay, so that's all inside the customer's housing. Now I need to work on the customer's Southbridge board. And we don't need that, because we're going to be focusing just on this board right here. So let's unplug that. Unplug that. And now I can have a look at this board. So what I'm thinking here is this board has gone bad, and that's caused the power supply to fry, or it's sent a power surge through this board, and when the power supply itself has died. So yeah, we need to figure out what has actually gone on with this board now. What damage has this power supply caused to this board, or what damage has caused this power supply to go bad? We don't know the exact situation. We're never going to know. But we can try and find out what's going on. At least it's a more interesting repair than just a power supply replacement, right? So let's have a look. So I'm going to do what I always do, and I'm going to start on the fan connector and the Nexus connector. So the Nexus connector, that's Microsoft's code name for the Southbridge, for the power button board. So I don't know why they called it Nexus. Maybe someone in the chat knows. Maybe someone in the comments knows. Chat. I'm used to doing live streams. But yeah, maybe someone in the comments knows. But what I'm going to do is I'm just going to look in some common areas first and just try and find a short here. So in continuity mode, we have no short on the Nexus connector, or at least not on the main power rail. What about the fan? No short, okay. So we don't have a short in those common areas. So now let's check some more areas. So we've got 3P3 FTDI. That's not short. And this is going to go in and out of focus because it's, you know, the way the board is designed and stuff. I don't use PCB holders because it makes it impossible to keep my hands steady with a PCB holder. So yeah, it's going to go in and out of focus, but it is what it is, unfortunately. We don't have a short on the disk drive main input. Or main output to the disk drive, rather. Main input to the disk drive isn't short. What about the 5-volt rail? That's not short. What about these caps around here? Because this is a common failure point. Nope, that's not short. Okay. What about disk drive power? Nope. No shorts. Okay. And I see the problem. This is where the magic smoke has come from, and this is what has fried the power supply. I should have just looked first. We have a lot of damaged components around here. So this has obviously gone bad. This transistor here. What area is this for? It's 1.1 volts standby. Ooh. And that is dead short to ground. Well, it's 4 ohms. But yeah, this is where the problem lies. So we need to obviously remove some of these components, and we're going to need to replace them. So this is 1.8 volts standby. That's what this circuit is. So what it's going to do is it's going to take, for example, I think 3.3 volts in. Let's have a look on the other side. No, there's nothing on the other side. I can find out on the schematic what it takes in, but it's U34, which looks like it looks like that's gone bad. So obviously the it's 1.1 volt standby, not 1.8. So it looks like the U34 has gone bad, and that's caused either that's caused the power supply to blow, or this. Or the power supply has caused this to blow. Like I said, we're never really going to know what's actually gone on here to the letter. We can make educated guesses, but honestly, we may as well just, act like apes here. Monkey see, monkey do. I see damaged component, I replace damaged component. But that's basically the gist of it here. Is we don't need to get all big brain with this and try and figure out exactly why it's blown. All we know is that the two components have obviously gone bad, and we need to replace them, right? So that's what we're going to do. And hopefully it hasn't burnt through the board. So I'm going to set my hot air up at 440 degrees Celsius, and that's going to be at 40% airflow. And I'm going to desolder this transistor, which is very obviously dead. Okay, it has kind of welded itself to the board a little bit. Yeah. So we're going to need to do a little bit of surgery here, really, and try and fix this up. Yeah, so it's damaged the trace here, and obviously it's going to need to be probably ground away a little bit. So I'm going to add some flux here, and I'm going to just tin these pads, and that'll basically clean it up to the point where we can get a better understanding of what's actually going on with the traces themselves. I know we've got at least one trace which is lifted up here, but how many are we going to need to dig away? Are we going to need to dig away and stuff like that? So if my soldering iron tip ever wanted to work, I need to clean it really. I didn't clean it after the last job. It doesn't help that I'm using solder which is just way too thick. Right, okay, so yeah, we've got, it doesn't help that there's too much solder here, but we've got some traces here which are damaged. So there's at least two from what I can tell. Just get rid of that blob of solder. I really shouldn't be using the micro pencil with 0.8mm solder. Yeah, so that trace is gone, definitely. Okay, so that's going to have to come away. So I broke that away. It basically just snapped off anyway. So that trace is gone. And then this trace here is going to have to be cut back as well, because there's going to be some damage to the substrate underneath, and that's going to cause it to short internally and probably end up blowing another power supply when we do restore power to it. So we're going to need to fix that up. Okay, so what I'm going to do now then is, if I just give this a little bit of a clean, so I'm going to use some isopropyl alcohol. So yeah, once this is actually cleaned up and stuff, you can get a better idea of what's actually going on with it. So we've obviously got some damage to the trace here. I think a grinding pen's in order here a little bit, just to clean this up. Okay. But what I'm going to need to do here is just look underneath here and just see if it's actually caused any damage to the substrate. I don't think it has. Not on this pad at least. I don't think the substrate is burnt. So basically, a motherboard, or a modern motherboard these days, isn't just one layer. So the traces that we see, they're not all there is that's going on. So can you see these holes in the board here? These are called vias, and basically that's like a pathway to another trace, right? So there's multiple layers. You're talking 6, 8, 10, 12 layers. And I haven't counted these, but most boards have got around about 7 or 8 layers, right? And the wires just connect everything together. So what happens is they sandwich it all together with substrate in between. So it's like a fiberglass material of some sort. And basically what that does is it prevents the layers from shorting out amongst each other, because then they can stack layers on top of each other, kind of like a cake. And basically the substrate prevents the layers from shorting out. So if you get too much heat applied in one area, what that will do is it'll burn away this fiberglass, it'll burn away this substrate, and that will cause the layers to become short across each other. So if you've got burning on the substrate, you need to clean it up before you can really go any further. So I'm just going to grind away a little bit, get rid of some of this blackening from off here, some of this burning. And I just want to inspect underneath it. So after I've ground away a little bit, I can inspect it and see exactly what's going on. You know, is it short? Is it burnt? Is it, you know, is it fused together? And I think in this case it's not. I think the customer's probably got really lucky here in the fact that we're just going to need to run a couple of micro jumpers just to reconnect the pins up themselves. So because this is damaged here, I'm going to get rid of that. So I'm just going to break that away, because it's damaged anyway. So we may as well break it away from there. We're going to have to run a jumper either way, so it doesn't matter. And then this one, well, I mean, it's pretty much broken away anyway, but I am going to just clean it up a little bit. So I'll get rid of this little bit of excess copper here that's serving absolutely no purpose. There we are. And then what I'm going to have to do is just run a couple of jumper wires. So the easiest way to run the jumper wires is going to be before we replace the component. So the reason for that is because once we've run the jumper wires, or once we've installed the component, we're not going to be able to access the pins. We're going to have to bend around components, and you know, it's just really, it's just a pain in the backside, to be honest. So I'm going to just tin up this area, and I'm going to have to hold the board down. So let's just get it back in focus for being held down. So I need to rest my hand on it just to hold it steady. Let's just tin these areas here. There we are. We don't want to leave that bridge there. I just had too much solder. So I'll just re-tin that. There we go. Basically just collect up some of this excess solder because there's too much there. There we are. And then I'm going to grab some jumper wire. And this jumper wire that I'm going to be using is 1.7mm thick. And I don't think I can buy this jumper wire. I took it from a microwave. So the fan inside a microwave, I basically stripped that down and took the jumper wire from it. I've had this for about 5 years now, and it's basically enough to last a lifetime. I haven't even touched the sides yet. Alright, so this jumper wire here, I'm going to do first. I'm just going to solder a wire to here, if I can. It's really awkward because I'm holding the board in position at the same time. Yes, I know I could get a board holder, but board holders are for rookies, alright. Alright, so to get that fully in position there, and then I'm going to come in with my tweezers, press and hold on it so as it stays in position, and just make sure we get a nice connection on that. Beautiful. Perfect. There we are. So there's that one. I'm going to come in and trim this off. There we are. And then we can come in with the second jumper. And I'm going to burn off the enamel just to allow me to solder to this wire. Just like that. Beautiful. And then I can break off the excess. And then what I'm going to do is just heat up this area just to, number one, allow these wires to flow into place fully. And number two, to remelt the flux so as I can clean it up easier. Good. So what I can do now is just grab a donor board and get some replacement components. So here's one I made earlier. I'm going to remove that component from there, and I'm going to, well, first of all, just double check underneath and make sure that we've got no ground points, but there isn't. I'll just flip it over to make sure there's no ground underneath, because otherwise I would have had to basically protect this area with conformal coating. But I'll just partially solder that chip on, add some flux, and then I can press down on the chip and make sure that it's flush to the board. And yes, we've had a little bit of solder squeeze out from underneath there, but that's fine. It shouldn't cause a bridge. I will confirm it though, just to make 100% sure. Obviously I don't want to cause any kind of bridging, but before I do that, I'm just going to add a little bit more flux here, and I'm going to just touch up these solder joints. To be honest, the micro pencil is probably the wrong thing to use right now, so I'm going to switch over to a normal iron. So I'm just going to flow these down, and then completely mess it up and bridge everything. Alright, let's wick it away. Okay. There we are. Okay, so we've got a little bit of excess wire there, which needs to be broken away. So this excess wire, I don't want to have any risk of bridging, so I'll just trim that, and then I'm going to check and make sure we don't have any bridging. So meter in continuity mode here. So first of all, let's check for bridges from pin to pin. Oh, hang on. Oh, it's 26 ohms. Alright, never mind. It's not dead short. Yeah, so that's fine. So always check that there and make sure. So we have no bridges there. That's 26 ohms again. So yeah, that's fine. One of them is going to be a ground and a low resistance reading being a 1.8 volt line. So yeah, I would expect that. So next I'm going to just check and make sure that this pin here, so the top of this pin is connected there, and it is, that's dead short, okay. And I'm going to make sure that this pin here is connected to here, and that's dead short, so it is. So we do have a connection between the pins where they're meant to go to, and we don't have any shorts. Yes, it did beep on some of the pins, but it's a 1.1 volt line and it's low impedance. It was 26 ohms, and my meter beeps at anything below 50 ohms, so that is completely normal. But now the true question, does this work? We're about to find out in a minute. No, we still don't get power, so something else has gone, something else has failed here. So we should be getting 12 volts up there. That's in resistance mode, never mind. So we're getting 12 volts here. We do. We don't get 3.3, but I don't think that FTDI line actually powers on until we get power in the board, until it actually turns on. So no, that's fine. We get 12 volts down here. We have 5 volts. We've got 12 volts there. We've got 1.8. And we've got 1.1 back. Do we have a 3.3 volt standby? We do. So this should be powering on. And it's not. So we've got the rail back here. We've got the 1.1 volt rail back. If you just take a look at my multimeter here, this 1.1 volt rail which we had is back. So we get 1.1 volt, and that is very, very stable as well. 1.10, 1.11. Like, it's not bouncing around much. It's you know, it's really, really stable voltage. That is working absolutely fine. This should be trying to power on, and it's not. It's just dead. I really, really hope that this hasn't killed the BIOS chip, because that is going to be really, really bad news if it has. Okay, I'm not seeing anything, and there's really not much to see on the other side. If it's killed the safe bridge, which it is possible that it could have done, if it's taken out the safe bridge, it's really not economically viable to actually replace that. So what I would do in that case is just do a board swap and swap the safe bridge board for another one. So I think that's what I'm going to do. So here's what I'm going to do. First of all, I'm going to take this customer's BIOS off this board. So the BIOS is this chip here. It says well, I read it as VBox, V80X. So this is the BIOS chip, U25. And this is required, same as on the PlayStation, the BIOS chip is required for it to attempt to power on. So if, for example, we've got a damaged BIOS chip, then it's not going to work. The problem is, if we have a BIOS chip which is basically screwed, we can't swap it. So there's the customer's BIOS chip. So what I'm going to do is, rather than removing the work that I've just done, I'm going to remove the BIOS chip from this donor board, and I'm going to put the BIOS chip from this donor board onto the customer's board, and then see if it attempts to power on. And the reason I'm going to do that is basically because then I can just confirm whether or not the customer's BIOS is working. So if this still doesn't attempt to power on with the customer's, well, with this BIOS on the customer's board, then I know it's an issue with this board, and at this point it's probably going to be more economically viable to replace the safe bridge board. So the reason I'm doing it this way instead of putting the customer's BIOS onto another board is purely because I've just done trace repair on this safe bridge board, and I don't want to undo that unless I have to. Alright, so that's had a replacement BIOS installed. Now let's go ahead and see if this customer's safe bridge board attempts to power on. No. Okay, that's good news. Alright. That is good news. Or at least I think it's good news. I hope it's good news. God, I hope it's good news. Let me just double check. Oh, hang on. Wait, is that the wrong power supply again? Wow, I really need to move these faulty power supplies out of the way, I think. Okay, doesn't power on with that one either. Okay, but that is the good power supply. But okay, that is good news then. Yeah. So that's great news. So that means that this BIOS chip should work in theory. So this board is still faulty. It's probably the safe bridge that's fried, because the 1.8 volt lines come from the safe bridge. Sorry, 1.1 and 1.8 volt lines come from the safe bridge, or they go through the safe bridge at least. So it's probably fried the safe bridge, right? So here's what I'm going to do now. I'm going to take this board, this donor board, which I've got right here. I'm going to put the customer's BIOS on it. I'm going to take this chip here that I've just taken off this board, and I'm going to put that back onto this board. And I'm going to do a full board swap, because it's just not really economical to actually sit there and replace the safe bridge. You know, on the off chance that it's just blowing a random component, right? And finding a random component is just, yeah, it's just a waste of time. It really is just a waste of time at that point. Alright, and just realised that was out of focus, but never mind. Alright, there we go. So I've been filming now for an hour and 11 minutes, so it's almost at a point where I really want to be done with this. Okay, so there's that. And then the customer's BIOS. Roughly in place. And there's the customer's BIOS. So now, in theory, this board is to the customer's console. I'm going to take the power supply ready. I'm not going to plug it in yet because it's too hot. But I'm going to take the power supply ready. Get everything ready for testing. It's actually not too hot. It's absolutely fine. Please power on. Oh, no. Oh, that sucks. That sucks, man. Oh, that sucks, man. That really, really sucks. Oh. Well, that just about sums it then, doesn't it? This board or this console can't be fixed because we can't replace this Southbridge board. If I could access the BIOS, yeah, fine. But it looks like whatever's happened to this, it's some sort of a big power surge. It's fried the power supply. It's fried the 1.1 volt line. And it looks like it's fried the BIOS and the Southbridge itself. Or something else on the board has fried, and yeah, these just don't even attempt to power on. So yeah, I'm gonna have to no-fix it, unfortunately. There's not really a lot I can do, I suppose.
But wait, there's more.
But I'll take. Actually, you know what? I'm gonna take one more Southbridge board. I'm gonna take my. This is a big risk, just for the video's sake. This is a big, big risk that I'm taking here. I'm going to take my Southbridge board. I'm going to put the customer's BIOS onto my Southbridge board and just make 100% sure. I want to make 100% sure here because too many people say that I don't know what I'm talking about and stuff. And yeah, I mean, I could be wrong. This board could be dead. This is a donor board after all, and I do need a known working board to be able to do this. So here's what I'm going to do. I'm going to take my BIOS off carefully because I don't want to fry my own BIOS. If I do, I've just lost basically £200. Even more than that, really. I mean, I'd be able to sell the parts, so it wouldn't really hurt. And I really should not be using my own parts to fix a customer's console. This is not recommended, people. Do not do this. I'm doing this purely for the, just for the learning curve, just for the education, right? You really should not be using your own consoles, working consoles, to fix other consoles. Alright, my BIOS. Ah! I'm stuck. Get off. Customer's BIOS. Customer's BIOS on my board. This could be a big mistake. Well, I'll be damned. That board's dead. Well, bite me. Bite me. Alright. See if the customer's console powers up. Cool. Sort of, I guess. Right. That's together enough to test. The console should in theory power on fully. Yes, we've got the double flash. Brilliant. Oh, thank goodness for that. There's the Xbox logo, baby. Let's go. All right, let's just wait for this to fully boot, and there we go. That is working. Awesome. So, yeah, I need to work out what it's going to cost for a working Southbridge board, because unfortunately, I can't really fix the customers. I don't think it's economically viable. Just a Southbridge chip on its own costs £40. So I think a working board is probably going to cost like £80. So this customer, honestly, this is probably going to be an £150 repair if the customer wants it doing. Otherwise, I'm going to have to reverse everything that I've already done and put it back as a no-fix, unfortunately, or offer to buy it off the customer because of it being expensive. So, just for context, this is out of warranty. Microsoft would charge £240 for this, for an out of warranty repair. That is what they charge. I can do it cheaper. So the problem is, we've got a power supply, we've got a safe bridge board, and then my time as well, right? So, I mean, realistically, yes, I can put, I can drop prices a little bit because, it's not costing me £80 for a safe bridge board. I have got safe bridge boards. Obviously, if it comes to where the customer agrees to this price, I need to work it out. I need to look at some prices online. But I think probably around about £150 seems reasonable to me for this because, I mean, I've got to put a safe bridge board on it. I've got to put a power supply on it. And obviously then there's my time to actually diagnose it and fault find it and get the console working as well. So, yeah, it is what it is. But, yeah, never mind. Anyway, at the moment, as it stands, whether the customer agrees to the prices or not, it's working. We figured out the issue, at least for the video's sake, right? Because, well, people keep whinging at me for putting out no fix videos. So, yeah, there you go. This is what you end up with. Anyway, thank you very much for watching. I really appreciate it. Let me know what you think down in the comment section down below. What do you think's happened to that safe bridge board? Because, honestly, I haven't got a clue. I know we had a big hole in it, but other than that, I don't know. So, yeah, let me know what you think, and thank you for watching. If you're new to the channel, don't forget to subscribe. If you need parts and supplies, you can get those on my online store, consolefix.shop, and if you need to book in a repair, you can get in touch with me at thecoder.repair. Linked in the video description, as well as all the links to the tools and stuff that I use in the videos. They are affiliate links. They do help me out when you use those links, and, yeah, give me some money. So, yeah, thank you for watching. I'll see you next time. Bye for now.